Hi guys! So today, we're going to discuss mathematical language and symbols. But before we go to the topic, let us define what a language is. Now, a language is a complex system of words and symbols, either spoken or words, and is used for communication. It is a systematic means of communicating by the use of sounds or conventional symbols. When we say conventional symbol, it is a symbol that has widely accepted interpretations, like conventionalized signs, sounds, or maybe gestures, or marks having understood meanings. Language allows us to use or express ideas to others. It is used to inform others, to ask them to do certain things, or maybe to express feelings, moods, ideas, informations, and some experiences. Now, in mathematics, it is full of terminologies and notations. It uses numbers, sets, functions, and even perform operations. These are the most commonly used symbols in mathematics. The first one are the 10 digits. So from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The next one are the operational symbols. We have the addition symbol, the subtraction symbol, multiplication, and the division symbol. Now the third one are the symbols that we use to denote for sets. We have the intersection symbol, the union symbol, the subset, and the superset. The fourth one are the variables, or the symbols that we use to denote variables. Remember that in denoting a variable, we make use of the small letters. You have A, B, C, X, and Y. These are the most commonly used symbols that we denote for variables. But actually, we can make use of all the letters in the alphabet to denote a variable. The next one are the special symbols. We have the equal sign, the greater than or less than sign. We can also use the less than or equal to sign or symbol, the greater than or equal to symbol, and even the pi symbol. Now in logic, we also have different symbols that we use. The negation symbol, the disjunction symbol, or the and symbol. We also have the conjunction symbol or the or symbol. This one refers or denotes for implies, and this one is for if and only if. The next one is the symbols that we used for set notations. And here is used to denote the set of natural numbers. This one is the set of whole numbers. This one is the set of integers. Q is the set of rational numbers. R is the set of all real numbers. And C is the set of complex numbers. Now these are some important sets are the following. For the set of natural numbers or the set of counting numbers, we start from 1. So from 1, 2, 3 up to infinity. Now, the set of whole numbers, we include 0. So from 0 up to infinity. Now, the set of integers, when we say integers, of course, these are signed numbers. But remember that 0 is also an integer. So when we say the set of integers, that includes the negative numbers, 0, and the positive numbers. The set Q there is the set of rational numbers. Q, or the complement of Q, is the set of irrational numbers, and R is the set of real numbers, and C is the set of complex numbers. Now, these are the different symbols that we use in mathematics. These are the common use or the basic symbols in math. This one is for higher math. This one is for grouping symbols. We have the braces, the brackets, and the parentheses. These are commonly used in geometry. This one is for mostly algebraic expressions. All right? You have to remember this one, this is used for logic. All right. So the characteristics of mathematics or mathematical language has three. All right. The first one is the mathematical language is precise, meaning it is able to make very fine distinctions. It is also concise. We can say things briefly. And it is also powerful, meaning it's able to express complex thoughts with relative ease. Now, these are the common difficulties that we encounter in dealing with mathematical language. The word is could mean equality, or it could also mean inequality, or a member in a set. Let's say is equal to. That means equality, used for equality symbol. You say is not equal to, that is inequality. Or if we are talking, if it is a member of a set, we might say is an element of. So we make use of the word is there. The next one, different use of a number, cardinal, ordinal, nominal, or ratio. Ratio, that is very common to us. Ratio is the comparison of two values. When we say cardinal numbers, that is, these are numbers that that is known as counting numbers. We say ordinal numbers, it indicates order of things or rank of things. Let's say, for example, you are in the 5th line, or you are ranked, you are the first rank, or maybe you are in the 6th line. So that is ordinal numbers. When we say nominal numbers, these are numbers or name or identify things like zip code, or the number that the player used in a team. So that is a nominal number. Mathematical objects may be represented in many ways, such as sets and functions. Just like what we've discussed a while ago, we make use of R to denote or to represent the sets of real numbers. We make use of N to denote the sets of natural numbers or counting numbers. W for the sets of whole numbers. All right? Now, the words and or mean differently in mathematics from its English use. If we're talking about, if you use and or in logic, and is for conjunction, or is for disjunction. And if we use and or in probability, and means that the outcome has to satisfy both conditions at the same time. On the other hand, or in probability means that the outcome has to satisfy one condition or the other condition, or both the same time. So it means differently in mathematics from its English use. Now, I want you to describe the error in each of the following. Let's have this one. 5 is a subset of natural numbers, or the set of natural numbers. Is there an error here? All right. So there is no error in the statement because 5 is a natural number. So we all know that 5 is a counting number. So meaning 5 is an element, or is a subset of n, or natural numbers. The next one, given the function x plus 10, find the value of f of 4. Is there an error here? Yes, actually there is an error here because x is not a function. It is an expression. We can say if it's a function, if it is in the form of f of x is equal to y. So x plus 10 there is an expression. It should be written in the form y is equal to x plus 10. Next, the ordered pair 1 1, comma 2 is an element of f where f is a function. Okay, so there is no error in the statement because 1, comma 2 is an ordered pair associated with the function. The next one is x is greater than 2 or x is less than 1 is equivalent to x is greater than 2 but less than 1. So, correct. There is no error in the statement, right? Okay, now let us translate each sentence using mathematical symbols. We make use of the different symbols that we've discussed a while ago. 0 is an integer. So what is the symbol that we use for integer? Okay, so we make use of the capital letter Z. So if we are going to translate this into mathematical symbols, this is how it looks like. So 0 is an integer. Next, x is multiple of 5. Or x is a multiple of 5. So what are the multiples of 5? So we have 5, 10, 15, 5 times 4 is 20, 5 times 5 is 25. So if we're going to translate this, that would be x is equal to, so we make use of the grouping symbols, the bracket. So 5, 10, 15, and so on. Next, x is an odd number. So what are the odd numbers? So we have 1, 3, 5, 7, 9, 11, and so on. So it looks like this. So 1, 3, 5, and so on. So the values of x range from -2 to 5. So in here, we can make use of the greater than or equal to symbols. Right? So we have here x is greater than or equal to -2 but less than or equal to 5. That is how we translate that sentence using mathematical symbols. Now, do you have any questions? If you don't have any questions, if you have questions, by the way, you can find me at Jane Gadiane Beligani. Thank you for watching.